Hello, today we are going to take a look at capacitors. Now, we've all learned about resistors in high school. They absorb energy from a voltage source and they release that energy in the form of heat or light. However, modern circuits cannot only rely on resistors and voltages to do their thing. So we can also use capacitors. What they do is that they store charge and they can release that charge later on. How do they do this? Well, as you can see here, this is a normal circuit with a voltage source and a capacitor. Do take note that the gap here is very real and it's not just a symbol. Now, what's happening here is that the positive terminal of the battery is releasing electrons. However, due to the gap in the middle, they cannot cross over, and so they are forced to group up in the leftmost side of the capacitor. On the other side, the negative terminal of the battery is taking electrons from the rightmost side of the capacitor. So what we have here is an abundance of electrons on one side and an absence of electrons on the other side, creating a negative charge and a positive charge here. This is not unlike the battery itself, with positive charge on the other and negative charge on the other. Now, after the capacitor is said to be fully charged, you can take the voltage source out of the circuit and the capacitor will briefly discharge all of its charge across the entire circuit. We can measure how much charge they accumulate by using this equation. The capacitance of a material is said to be the charge it has accumulated divided by the voltage that has been pumped into it. The SI unit for capacitance is called the farads. Now, do take note that the capacitance is said to be a constant of the material itself. It is not changed by the amount of charge it can carry or the voltage we pump into it. It stays constant. Going on that, we can measure. There is another equation to measure the capacitance of a material. Its capacitance is equal to the E, or the permittivity of a capacitor, which depends on the material, multiplied by the area of one section of the capacitor, divided by the distance between the two sections of the capacitor. How do we measure capacitance across an entire circuit? Well, here's how. Now, the trick of this is to realize that the equations we use to measure the capacitance are literally the opposite of the equations we use to measure resistance. For example, in a series circuit, you use the equation for the parallel resistance. Likewise, in a parallel circuit, we use the equation for a series resistance. That's it. Thank you.